Okay, so number 1, part D. Part D says that for times t is greater than or equal to 0, less than or equal to 300, at what time t is the number of people in line a minimum to the nearest whole number? So, in order to do this, we must find out the critical points, and those are where endpoints and the slope is equal to 0. So, we know that at the number of people in line at times t equals 0 is 20. Scoot that down a bit. And then we know that the number of people in line at p equals 300 is equal to 80. So now we have to find times at which the slope is equal to 0. And to do this, we can put p prime t into our calculators, and we'll find the time at which that is equal to 0. So that occurs at 2 times. The first one being t is equal to 33.013298. We can store that for now as a, and t equals 166.57472. And for now we can store that as b. So to find the number of people in line at these times, we would plug it back in to our big equation to find the number of people in line at any time. So we would plug it into like this: p of a equal integral from 0 to a r of t d of t minus 0.7 times a. That will give us an answer of approximately 3.8 people. Now we would do the same thing for times t equal to b. So p of b is equal to integral 0 to b r of t d of t minus 0.7 times b. And that gives us an answer approximately of 158.07 people. So out of all of our critical points, the time at which the number of people in line is at a minimum would be times t equals a. So the question asks, what time t is the number of people in line a minimum to the nearest whole number? So that would be times t equal to 33 seconds.